The Mystery of Nanoflares, presented by Science at NASA. When you attach the prefix nano to something, it usually means very small. Solar flares appear to be the exception. But researchers are studying a type of explosion on the Sun called a nanoflare. 1,000,000,000 times less energetic than ordinary flares, nanoflares nevertheless have a strength that belies their name. A typical nanoflare has the same energy as 240 megatons of TNT, says physicist David Smith of UC Santa Cruz. That would be something like 10,000 atomic fission bombs. The Sun can go days, weeks, or even months without producing large solar flares. Nanoflares, on the other hand, are crackling on the Sun almost non-stop. They appear as little brightenings of the solar surface at extreme ultraviolet and X-ray wavelengths, continues Smith. The first sightings go back to Skylab in the 1970s. The relentless crackle of nanoflares might solve a long-standing mystery in solar physics. What causes the Sun's corona to be so hot? Imagine standing in front of a roaring fire. You feel the warmth of the flames. Now back away. You get cooler, right? That's not how it works on the Sun. The visible surface of the Sun, called the photosphere, has a temperature of 5,500 degrees Celsius. Moving away from the surface should provide some relief. Instead, the Sun's upper atmosphere, known as the solar corona, sizzles at 1,000,000 degrees, a temperature almost 200 times higher than that of the roaring furnace below. For more than a half-century, astronomers have tried to figure out what causes the corona to be so hot. Every year or so, a press release appears purporting to solve the mystery, only to be replaced by a competing theory a year or so later. It is one of the most vexing problems in astrophysics. Smith thinks nanoflares might be involved. For one thing, they appear to be active throughout the solar cycle. Over the course of about 11 years, the Sun cycles through periods of high and low solar activity, referred to as solar maximum and solar minimum respectively. While the frequency of large solar flares is affected by this cycle, nanoflare activity appears to remain constant, which could explain why the corona remains hot even during solar minimum. While each individual nanoflare falls far short of the energy required to heat the Sun's atmosphere, collectively, they might have no trouble doing the job. To investigate this possibility, Smith turned to a telescope designed to study something completely different. Launched in 2012, NASA's NuSTAR X-ray telescope's primary mission is to study black holes and other extreme objects in the distant cosmos. Solar scientists first thought of using NuSTAR to study the Sun about 7 years ago, after the space telescope's design and construction was underway. Smith contacted the principal investigator, Fiona Harrison of the California Institute of Technology in Pasadena, to see what she thought. "At first, I thought the whole idea was crazy," says Harrison. "Why would we have the most sensitive high-energy X-ray telescope ever built, designed to peer deep into the universe, look at something in our own backyard?" Eventually, she was convinced. As Smith explained, NuSTAR has just the right combination of sensitivity and resolution to study the telltale X-ray flickers of nanoflares. A test image they took in late 2014 removed any doubt. NuSTAR turned toward the Sun and, working together with NASA's Solar Dynamics Observatory, captured one of the most beautiful images in the history of solar astronomy. The next step, says Smith, is to wait for solar minimum. Having just passed solar maximum, the current solar cycle will wind down in the next few years, leaving the Sun mostly free of sunspots and other magnetic clutter that can obscure nanoflares. NuSTAR will be able to survey the stellar surface and gather data on these explosions like no telescope has done before. Will it solve the mystery of nanoflares and the solar corona? I don't know, says Smith, but I cannot wait to try. For more information about powerful explosions, nano and otherwise, stay tuned to science.nasa.gov.